MLOPS assignment group 92. Here we have developed an end-to-end application for binary image classification cats versus dogs for an online pet portal, wherein all the code has been stored as part of Git, versioned using Git, and the src directory contains all the required Python files, wherein app.py contain the fast API endpoints. Dataset.py is used for data curation. Info.py contains the inference classes. The model.py contains the CNN model class, as well as the train.py contains the training application code for the model. Apart from that, we have also written some scripts for data setup, which actually gets all the required image data from the Kaggle, as well as smoketest.sh to perform the final smoke test. Apart from that, the data is also versioned using .dvcs. The .dvc files are raw.dvc, process.dvc, and subset.dvc, which contains the data information with the unique IDs. Apart from that, the experiment tracking has been performed using the ML flow. So let's quickly. So here we have the cats versus dogs experiments, wherein this is one of the experiment which was run lately. So this contains a training loss of 0.66, value accuracy of 0.5, and test accuracy of 0.4. Here we have run 5 epochs with batch size of 32 each. Apart from that, we are also storing the model metrics of test accuracy, training loss, value accuracy for all the epochs that we have. Apart from that, the model artifacts are also being stored as the artifacts for every experiment that we run. Packaging and containerization. The trained model is hosted in a Kubernetes environment with its public API exposed, containing the metrics, health, as well as predict endpoints. All specific required libraries are set in the requirements.txt file, which contains all the libraries along with their specific versions that are being in use, as well as a Docker file for containerization of inference service is also being maintained. In testing, we are using PyTest, wherein all the test files are maintained under the test directory for all the Python files that we have as part of SRC. So along with that, these PyTest is being run as part of the CI workflow, which we are using via GitHub Actions. If we go through one of the run of the GitHub for CI, we could see the steps that are there over here. So we run unit tests with coverage, ensure model artifact tree exists, we build a Docker image, we run the service container, smoke tests are performed on that container, we capture the container logs, as well as we then upload these CI reports as part of every individual run. Then we log into the Docker Hub, tag appropriately for the Docker Hub image. Then we push that image to the Docker Hub. So we utilize Docker Hub as our image registry, wherein we have unique image tags for our MLOPS2 image, as well as the latest tag gets updated with individual run of the image. Apart from that, and we also maintain the CI reports. The CI reports contain the coverage.html, wherein we could see the code coverage, which shows around 94% over here, with individual assessments of the files, as well as we also have something called as smoke test report.txt, which contains this initial smoke test response that we got for a test prediction that we do. Part of the deployment is concerned, the application is deployed on a Kubernetes environment, wherein the deployment.yaml is used for the deployment of the application within the Kubernetes environment. Service.yaml is used for the application communication, as well as and virtual service has also been used over here for public API display, as well as this entire thing of the workflow has been automated using a continuous deployment, which again has been performed using the GitHub Actions. The GitHub Actions for CD gets triggered soon after the CI completes, and the CI is usually triggered after any main merge. The CD pipeline contains the steps of image pull from registry, deploying this service in the Kubernetes environment, and post deployment it performs the smoke tests and also stores the results in the artifactory, which we can see over here, which contains the smoke test results. Request response logging is enabled and can be viewed on container logs. So these are the requests of health as well as other endpoints, along with its response time that is getting noted. We have implemented a basic monitoring, in-app monitoring, using the request count as well as the latency for those responses as an average using the metrics endpoint. It is a get request, so we can simply execute it. So it shows that the total requests that have come in are 1898, wherein the health endpoint has been called 1896 times, metrics has been called one time, the predict endpoint has been called one, and any other endpoints if being maintained, it's being tracked over here. The average latency for it, sum of it is around 2.05 seconds, as well as latency seconds average we could see is of 0.001, which is very less. So apart from that, let's quickly move on to the predict endpoint, where it accepts a file, image file basically. So let's choose one cat image over here. So you can see the cat image. If you pass it onto the model, so we have gotten a response of cat with a confidence score of 0.5768. Rest all detailed information about the application usage as well as for application understanding has been maintained as part of the readme.md file, which contains all the installables, how to run the scripts, as well as the training of the models, the MLflow UI runs, testings using PyTest, Docker file, Docker build, run, compose, as well as we have the Kubernetes deployment, CI/CD runs, how they can be done, and what all steps that are being maintained within that, as well as the monitoring and logging within the README file, which can be followed for self-running of the application.